Number 16 says, for the function f of x equals the absolute value of 2x minus 6x, what value of c works for f of 3 minus f of c equals negative 24? What I would do first is we can take the 2x minus 6x and just reduce that. 2x minus 6x is actually negative 4x, makes it look a little simpler. And we need to ask, what are they looking for? If you haven't used functions for a little while, it may seem confusing. But they're saying this is like when they say f of 3, they're saying when we plug 3 in for x. Okay, so what we're going to do here is actually saying f of 3 would be the absolute value of negative 4 times 3, like that, minus f of what value, because we're looking for c, equals negative 24. Okay, now negative 4 times 3 is negative 12. And then you have to remember those two little bars is absolute value. And absolute value is the distance from 0, and it's always positive. So negative 12 is actually 12 from 0. So it's just positive 12. So what they're really asking for is 12 minus what equals negative 24. Okay, remember we're looking for f of c. Okay, now you could think about that and say 12 minus what would be negative 24? That's going to be 12 minus 36. Okay, so they're saying, for what value f of c would we get 36? That's the question. Okay, so we come over here and say negative 4 times whatever we're looking for would be 36. And I look at my answer choices and I know 4 times 9 is 36. Obviously, the negative is irrelevant with the absolute value, so B is the correct answer. Number 17. When considering the exponential function f of x equals g of h to the power of x, which of the following equations in the same form does g show the value for f of 0? Okay, the problems are starting to get harder. Just the way that they word them is very confusing sometimes. And so we have to look at, it says, what does g show the the value of, basically when is the input going to be 0? So we want to focus, where is g? We got 12, 15, 24, and 30. Those are my g's. So they're asking which of these four problems is when we plug in 0 for x, okay? When we plug in 0, which of those is going to end up resulting in an answer of where whatever g is there, okay? And so basically, what is any number to the power of 0? Remember the rule, and that's what they're testing you on here. They want to know, do you know what something to the power of 0 is? And it's always 1, okay? Like negative 5 to the power of 0 is 1. Just throwing out random numbers, 17 to the power of 0 is 1. It's always 1, okay? So even though this seems really confusing, it's actually just that one rule, okay? Now for B, when I plug a 0 in here, okay, the 1.25 to the power of 0 is going to be just 1, and therefore 15 is not going to change, unlike the other problems. So there you have it. Answer choice is B. Number 18. The number of views on a popular YouTube video a week after it was posted is represented by the function f of d equals 5,000 times 3 to the power of d over 15, where d is the number of days that have gone by. How many days will it take for the number of views to triple? Okay, this is an exponential growth problem. You'll notice here that 5,000 is actually the initial value. Okay, so that's this person has 5,000 views. Okay. And they're asking how long until it triples. So, well, triple would just be times three, right? So, what value of d would make this to the power of 1? Oh, 15 over 15 would be 1. So B is your correct answer there. Number 19. The variables b, c, and d above are all positive integers, and d is greater than c. Which expression would be the result of solving for b? Okay. The first part there could make you think, you have to do something interesting with, B and positive integers and D is greater than C. But all they're pointing out there is that if B, C, or D was negative, okay, then it would switch those fractions to, the positive would become negative, the negatives would become positives. So that part is not that important. It's just clarifying that those are not going to be negative numbers, meaning that that equation is not going to change. So we just want to isolate b. You've added and subtracted fractions before, but usually you always have maybe just one variable or no variables. And to have three different variables makes this a little tricky in the moment to figure out how you're going to address this. Okay. And so always glance at your answer choices. I noticed that all of these answer choices actually have a 4 instead of an 8 or a 2. And so for starters, I would actually rewrite this and I would divide the whole thing by 2. So this actually becomes 4 over b minus uh, 2 divided by 2 is just 1 over c equals negative 1 over d. Okay. Now, because we're trying to solve for b, okay, we want this all by itself. So we're going to go ahead and move the 1 over c to the other side by just adding 1 over c to both sides, canceling that out, giving us 4 over b equals 1 over c, which is now positive, minus 1 over d. Notice that is starting to look a lot closer to what the answer choices are. Now, the fractions, we can't add those fractions together until the denominator is the same. So if I were to multiply that part of the problem, just multiplying this by d over d, it doesn't change the value, but it does help us to combine those fractions. And then we're also going to go ahead and multiply this one by c over c so that we have a common denominator. Okay, so this is all going to simplify to that is now, if we look at just this part, that is d minus c over CD. Okay. And we have 4 over B here. To get rid of B there, we could multiply both sides by B, but that is actually going to create extra work. And so what I want to do here is I actually want to I can simply flip both of those fractions over like so. Okay, so the values didn't change there because if you cross multiplied, you'd still get the same results. And now to get rid of this divided by 4, to isolate b, I can actually multiply both sides by 4. Okay, we now have b all by itself, and I'm left with 4cd over d minus c, and that is an answer of C. Um, be careful, they might list it in DC and you solved it for CD. Just keep in mind the ordering in which they list the variables is not that important as long as what you get is equivalent to what they have. Again, this is one of the trickier questions in this module. May want to watch that one or two more times just to make sure you understand the process. And looking at number 20, we have a graph there. If we glance at it, we notice we have temperature on the y-axis in degrees Celsius. We have time passed in hours in the x-axis. It says Beginning at midnight, Julia recorded the outside temperature every hour for 8 hours. What was the average rate of change from 2 a.m. to 6 a.m. in degrees Celsius per hour? Okay, I think finding average rate of change, which is also known as slope, isn't too hard. And then making sure this is not multiple choice. So answering this in the correct way, in the way that they want it, is very important. So we notice the 0 for time passed is the beginning at midnight there. And so we actually, this here would be 2 a.m. We note that it's -3 degrees. So let's write that. So we got 2 a.m. would be -3 degrees Celsius. And then over here at 6 a.m., it is actually -9. So 6 a.m., it is -9. Now let's make sure we list this how they want it. They want the average rate of change in degrees Celsius per hour. Okay. So putting our slope, remember, slope is always you have your y, change in y in the numerator and change in x in the denominator. So let's think about that in terms of y and x. The slope from the temperature went down 6 degrees. So that -3 down to -9 was -6 degrees over the course of 4 hours. Okay. And if we simplify that in degrees Celsius per hour, -6 divided by 4 is -1.5 degrees Celsius per hour. And that's that.